Okay. All right, this is number 20, part B. And what we're going to do is we're going to continue. Now, we did the first three parts, and we found out where our velocity was 0, and we used our calculator. So you can see we're right over here where we ended up. Now we have to describe the motion, so this takes a little bit of time if we want to do it right. We have a general idea by looking at the velocity function. Again, what's going to happen. This is my velocity function, so I'm going to go left, then right, then left, and I'll be ended up going left for the rest of the duration. So what we have to do is get like a graph and see what's going on. So first of all, like we said before, where am I going to start? Well, I'm going to start at t equals 0. Starts at t greater than 0. So when t equals 0, that's where I'm going to start. So I put over here t at 0 is s of 0. And this is pretty easy if I put 0 into my function right up here. The t's all cancel, so all that's left is 8. So I'm going to start at 8. So s of 0 is 8. That's my beginning position. All right. And then I'm going to move to the left, as we said. We're going to move to the left, and we're going to move to the left until I get to t of 1.451 seconds. So after the first 1.451 seconds, I'll stop. But I'm moving to the left until then, because we looked at our velocity function. We could see that. We could also check our velocity. What's our velocity at 0? To find out what direction I'm going, if I put my velocity to 0, if you look at your velocity over here, at 0, I'm sorry, that's acceleration. If I look at my velocity at 0 over here, pardon me, 0, 0 is negative 14, so if I put 0 in for my velocity, it also reaffirms what my graph said. I'm going negative, I'm going to the left, so I'll start going to the left. And I'm going to stop after 1.451 seconds. Now, where am I going to stop? So we'll put that in over here. So this goes down here. T at 1.451. Okay, that's the T, so I want to find S of. So I'm going to put that back into my position function. So this is where we use the var y vars. So we go back over here and look at our calculator. All right, and again, over here I put this in the first equation, so that's going to be in y1. I don't have to clear it because it knows it's in y1. So I'll go to second quit, and I'll go var, and I go to y vars, enter, and there's function number 1. So that's already there, so I just press enter. I put a parentheses, and remember, this 1.451 is in alpha A. I stored it in alpha A because I'm going to use it now, so I'll put alpha A, parentheses, enter, and there's my position. All right, because I had my position function, so I put that into my position function to find out where I'm at 1.451 seconds, and this is where I'm at. So this is seconds. And this is my position, and my position is going to be negative 0.63, negative 0.631, and that's going to be in meters. So I can put that in meters, and that's a position. Okay? So here I have my when. Let me get this so you can see this. Get this up a little bit higher here, pardon me. Okay, so this is my when, and this is my where. So I'll put a mark there, so I'm going to go to negative 6.60. This is 0, so it's going to be a little bit more than half, so I'm going this far here. So I'm going from 8 all this way like that. So I can mark that in so I can see what's going on. Get a ruler here. Okay. And then I'm going to stop and turn around because I'm going to come back the other way, I think. Well, look, I am going to go right when I looked at my velocity graph. So I'm going to say my new time is going to be 3.215, and that was an alpha B. So I'm going to find out where I'm going to go there. So I'm going to stop here, and then I'm going to turn around. I'm going to come back in the other direction. So let's go back. Now this is real easy because once we have this in, all we have to do is go to second entry down here, second enter, and that's going to give me that same thing, and I can just scroll back and I can change that for alpha B. And that's going to give me my position at 3.215 seconds, and that's going to be 2.11. So that's going to be the position there. So at this 3.215 seconds, and this would be, again, I'm taking S of my position at 3.215 seconds. And the position I get is 2.113. I guess it'd be 113 because it rounds up to 3 places. And that would be meters. So that's my position there. So it's going to be a little bit past 2.1, so about 210. So I'm going to go right about over here. Then I could put a little marker there. I want to put that there. So I go this way, then I'm going to go back this way. Now this is going to be straight on the line, so I'm just going on the line, but this arrow kind of indicates the direction we're going. So that's where I go right. That's when my velocity was positive. And then I'm going to stop there, turn around, and then I'm going to go left for the rest of the trip. So again, by using your functions, you can find out the when and the where. So this is when I stopped, this is where I stopped, this is when I stopped, this is where I stopped. So I started at 8, moved to the left, stopped here at this time, then moved to the right, stopped here at this time, and then moved to the left. And you can see there's your left, right, left. That was indicated again by your velocity function, which is the graph I had. Left, right, left. Now if we describe that with all of our data, I wrote it down here at t equals 0 seconds. All right. The particle starts at the point s equals 8 meters and moves to the left until time t equals 1.451 seconds. When it stops at this position, negative 0.631 meters. It then moves to the right. And it still moves, and then it moves to the right until 3.215 seconds total time. When it stops at position s equals 2.113 meters, it then moves to the left from then on. So left, right, left. But actually it's on the line, so it's going to go like this, stop, come back, and go like that. So think about that. Make sure you thoroughly understand how to analyze those, because that's a valuable kind of problem to understand, especially in particle motion and physics.